Let's be honest. Have you ever really stopped to think about how the internet works? I mean, it just feels like magic, right? It's instant. But underneath that seamless experience is this incredible, globe-spanning journey. So today, we're going to pull back that curtain and see how it really all comes together.
So it all starts with something you do every day. You type a web address, you hit enter, and poof, the page is there. But that tiny little gap, that fraction of a second between your finger hitting the key and the website appearing, oh, that is packed with an absolutely wild sequence of events. Let's follow that journey together, step by step. You know, the best way to picture this first step is to think of it like you're sending a postcard, right? Before you can mail anything, you've got to write your message, you've got to figure out what you're asking for, and of course, you have to put the right address on it. Your computer is doing that exact same thing, just digitally. Okay, so what you see on the right, the nice, clean web page, that's just the final product. But that's not what your browser actually asks for. Nope. On the left, that's the real request. It's raw code called HTML. The browser's main job is to take all that code and basically translate it into the pretty, organized page you actually see. So, how does the browser write this request? Well, it doesn't just wing it. It uses a very specific language called HTTP, the Hypertext Transfer Protocol. You can just think of it as the official rulebook for web communication. It's the language that lets your browser write on our little digital postcard, hey, get me the HTML for this page. All right, so our postcard is written. We know what we want. But we've hit a snag. A website name like google.com is great for us humans, but it's not a real address that computers can actually use. See, computers on a network need a specific, unique number to find each other, an IP address. And the solution to this problem is something called the DNS, or Domain Name System. And honestly, it's pretty simple. It's the internet's phone book. Your computer sends the name google.com to a DNS server, it looks it up, and sends back the right IP address. And just like that, our digital postcard finally has a proper address. But wait, before we actually send the real request, there's one last little bit of digital politeness. Your computer wants to make sure that the server on the other end is actually there, and that it's ready to listen. So it does this super quick pre-flight check to make sure the connection is solid. This check is famously called the three-way handshake. It's really just a quick conversation. First, your computer sends a SYN packet, which is basically like yelling across a room, hey, can you hear me? The server on the other end replies with a SYN ACK, saying, yep, I hear you, I'm ready. And finally, your computer sends one last ACK to confirm. Awesome, my message is on its way. Now the line is open and stable. Okay, our postcard is written, it's addressed, and we've confirmed the recipient is ready and waiting. Now it's time for our little request to leave your immediate surroundings, your home, your office, and head out into the great wide world. The very first stop on its journey, probably just a few feet away, is a device called a switch. Now, its job is to manage traffic inside your local network. It's smart. It takes that data packet from your computer and sends it only to the port that leads out towards the internet. It's like a traffic cop for your house. After the switch, the packet arrives at the router, and this is the critical moment. The router is the gateway. It's the main door between your own private network and the huge public internet. This is the device that finally lets your data out into the world. So to recap the path so far, it goes from your computer to the switch to the router. And now the router has pushed that request out of your local network, and its grand adventure across the internet has truly begun. So now your request is out on the global internet, which is really just a massive tangled web of networks. You can think of what happens next as this incredibly complex relay race. And your little data packet is the baton. And this is maybe the most fundamental thing to understand. The internet isn't some magical cloud. It's a network of networks. It's a gigantic structure built for one reason: to connect millions of individual local area networks, like the one in your home or your office, from all over the planet. And this network of networks kind of has a ladder to it. Your request first goes to your local internet service provider, your Comcast or Verizon. From there, it gets handed off to a bigger regional network. And then finally, it jumps onto the massive backbone networks run by global ISPs that handle all the long-distance traffic. So this brings up a really interesting question. What happens when your request has to go from, say, North America to Europe? How does it physically get there? A lot of us probably picture satellites bouncing signals around, but the reality is way more down to earth, literally. This is an incredible fact. 99% of all international data travels through a massive, sprawling network of physical undersea fiber optic cables. Yeah, we're talking about millions of miles of cables laid across the ocean floor. That is the true physical backbone of our global internet. And how does your packet navigate this maze of networks and undersea cables? Well, there are countless routers out there. You can think of them all working together like a giant distributed GPS. They don't just follow one set path. They're constantly talking to each other, analyzing traffic, and calculating the absolute fastest and most efficient route for your data to take at that exact moment.
So, after traveling through local networks across continents and oceans and being intelligently routed every single step of the way, your request finally arrives at its destination. But the journey's only half over. Now, all that information has to make the entire trip back.
And that destination is a server. A server is basically just a really powerful computer that's always on, and its whole job is to serve up data. It gets your HTTP request, it understands you want the HTML code for a specific page, it finds the file and gets it ready to send back.
Then, the server sends that HTML code all packaged up into new data packets on the return trip. And those packets travel back across that same incredible infrastructure, navigating from global to regional to local ISPs, all the way back to your router at home. Once those packets arrive, your router passes them to your computer. And right here, we come full circle. Your web browser gets that raw HTML code that we saw way back at the beginning, and it does its final magical job. It reads all that code and renders it into the complete, interactive web page you can actually see and use. And this is the most mind-blowing part of the whole story. This entire process, the phone book lookup, the handshake, the package journey through switches and routers and cables under the ocean to a server on the other side of the planet, and the whole return trip, all of it happens in milliseconds. It is an absolutely astounding feat of engineering. You know, in the end, the internet isn't magic. It's a real, tangible, physical system of cables and routers and servers and rules, all designed, built, and maintained by people. It is one of the greatest collaborative projects in human history, all built on this desire to share information and connect with each other. And that just makes you wonder, what's the next great connection we're going to build?